In this video lecture, we will discuss about ideal. Ideal. So we define as let a non-empty subset S of a ring R is said to be ideal if. So first property we define as if A and B belongs to S, which implies that A minus B belongs to S. And second property, if R, small r, be the element of ring R and small s be the element of S, so which implies that RS belongs to S and SR belongs to S. So we can say that this is our left ideal. So this is the left ideal, and this is the right ideal. Okay, so we define the left or right ideal on the basis of the element of R. So small r be the element of ring R, small s be the element of set S. So if any non-empty subset of ring R, which follow these properties, that means right ideal and left ideal, so then it is said to be the ideal. So we can say that then said to be ideal. Now we take one theorem based on that. So we start the statement of the theorem. So prove that the intersection of two ideals the intersection of two ideals is again a ideal. So we shall prove this theorem by using the above definition. So that means first we take two ideals. So we consider as, so let I1 and I2 be two ideals. So then prove that. अब हम क्या प्रूव करने जा रहे हैं कि इंटरसेक्शन ऑफ टू आइडियल्स. सो दैट मींस प्रूव दैट I1 intersection I2 is also an ideal. So for proving this, that means ideal for what? Ideal of R. So that means ring R. So we can write down the ideal of ring R. So let A, B. So we consider A and B be two elements which belongs to I1 intersection I2. That is first condition. Here we see that A, B belongs to S. So now AB belongs to I1 intersection I2. So which implies that A belongs to, that means we can write down for both the elements. That means you can write down this as AB. AB belongs to I1 and AB belongs to I2. So because A and B both belongs to I1 intersection I2, so then AB belongs to I1 and AB belongs to I2. So now we see that So that may prove that the intersection of two ideals is again a ideal. So that means we say that but I is an ideal. So when I is an ideal, so that means the first property we can write down as A minus B, which belongs to I1 by definition of ideal. So A minus B belongs to I1. Similarly, you can write down for second one. So similarly, I2, that here we write on I1. So similarly, I2 is also an ideal, also an ideal. So we write down as A minus B is also belongs to I2. A minus B also belongs to I2. So we see that when A minus B belongs to I1, A minus B belongs to I2. So then we can say that A minus B belongs to I1 intersection I2. तो ये फर्स्ट कंडीशन थी हमारी कि अगर A और B I1 इंटरसेक्शन I2 के एलिमेंट है तो A माइनस बी भी I1 इंटरसेक्शन I2 का एलिमेंट होना चाहिए. ओके, नाउ अगेन अब लेफ्ट आइडियल और राइट आइडियल के लिए. सो अगेन वी अज्यूम दैट small r belongs to ring R and small s which belongs to I1 intersection I2. So I1 intersection I2. So I1 intersection I2 is subset of R. So now we can write down this as S belongs to I1 and S belongs to I2. So we know that what we know that I1 is an ideal. So I1 is an ideal. So from this we can say that R belongs to R or S belongs to I1. So then RS. So then RS belongs to I1. So RS belongs to I1 and similarly we can write down SR. SR is also belongs to I1. तो ये definition है, definition का second part है. Now similarly for this one, similarly we say that I2 is an ideal. I2 is an ideal. So then we can write down as RS. RS belongs to I2 and SR belongs to I2. अब यहाँ पे हम देखते हैं कि जो RS है वो I1 को बिलोंग कर रहा है, RS हमारा I2 को बिलोंग कर रहा है. सिमिलरली SR belongs to I1 और SR belongs to I2. तो ये कहाँ से लिखा है हमने? We use the definition. तो यहाँ से हम भी क्या लिख सकते हैं? तो then RS. So RS belongs to I1 intersection I2. And similarly, SR also belongs to I1 intersection I2. So RS and SR, which belongs to I1 intersection I2. So then we can say that. So hence, we can say that I1 intersection I2 is an ideal. Is an ideal. Okay. Now we move to the next question. So before moving the question, we have one important remark. So remark is that every ideal is a subring. Every ideal is a subring, but every or better we can say that but a subring may or may not be an ideal. तो ये ध्यान रखना होगा कि जो भी आइडियल होगा, आइडियल की डेफिनेशन फॉलो कर रहा होगा, वो ऑलवेज ए सबरिंग होगा, बट सबरिंग मे और मे नॉट बी द आइडियल. नाउ वी मूव टू द next problem, that means we take one question based on this. So suppose we have a set n, the element of set n which represent a matrix of order 2 by 2, a0 and b0, or here we write down this as a and b both are the element of integer I. So prove that n is left ideal. N is left ideal, but not a right ideal. But not a right ideal of R. Right ideal of ring R. Or ring R, which is defined as where R is equal to, or ring R is defined as X, Y, Z, and T, where X, Y, Z, and T all are belongs to I, integer. So now we do the solution of this. So for solving, we shall prove that n is an left ideal. Okay, so n is an left ideal, or we can say that n is a subset of R. Obviously, yes. So now for solving this, so we assume that let A set लिया हमने कोई A set which contain the element in this form A, B, and 0, 0, which is 2 by 2 matrix, and set B we consider as C, D, 0, 0. तो function जो define है आपको n के form में, this is our set. So we can take element from this n. Okay, so ये दोनों किसको belong कर रहे हैं? Belongs to n कर रहे हैं. Now when we apply the first property apply करेंगे तो वहां क्या कैलकुलेट करना? A minus B. जब a minus b कैलकुलेट करेंगे तो this can be written as b0 minus c0 or d0. So we write down this as a minus c 0 or b minus d or 0. So this also belongs to natural number or not? Sorry, natural number set n. So this will also belongs to set n, because जो a minus c होगा, a minus c also belongs to I, और b minus d होगा which also belongs to I. So this is not a natural number, this is a set. Okay, so this belongs to set n. So belongs to set n, so that means first property satisfied. Okay, the first property satisfied. And now we move to the second property. So second property we consider as R. Small r we consider as X, Y, Z, T. जो R का एलिमेंट होगा वो स्मॉल r जो होगा वो R का एलिमेंट होगा, दिस बिलोंग्स टू करेगा किसको? R को. और जो S होगा, S इज इक्वल टू वो किसका एलिमेंट होगा? वो N का एलिमेंट होगा इस सेट S का. तो ये बिलोंग करेगा किसको? N को. अब जब हमें लेफ्ट को सेट और राइट को सेट चेक करना है तो फर्स्ट भी सेट चेक द लेफ्ट को सेट. लेफ्ट को सेट के लिए क्या हो जाएगा? R इंटू एस. सो R इंटू एस करेंगे तो ये क्या हो जाएगा? एक्स वाई जेड इंटू टी और मल्टीप्लाई ए बी 0, 0. दैट मीन 2 बाई 2 की मैट्रिक्स है दोनों. मल्टीप्लीकेशन करेंगे तो फर्स्ट रो फर्स्ट कॉलम. तो मल्टीप्लीकेशन के लिए क्या होगा? फर्स्ट रो फर्स्ट कॉलम करेंगे तो एक्स ए प्लस वाई बी. तो ये हो जाएगा हमारा ए एक्स प्लस बी वाई. ए एक्स प्लस बी वाई, और फर्स्ट रो का सेकंड कॉलम से करेंगे तो जीरो आ जाएगा, तो दोनों एलिमेंट जीरो उसमें. और सेकंड रो का फर्स्ट से करेंगे तो क्या आ जाएगा? ये आ जाएगा ए जेड प्लस बी टी. ए जेड प्लस बी टी और ये आ जाएगा जीरो. ए जेड प्लस बी टी और जीरो. तो इसको जब देख रहे हैं तो ये किसको बिलोंग कर रहा है? सेट एन को बिलोंग कर रहा है. तो एलिमेंट का जो नेचर है वो उसी फॉर्म में आ रहा है. सो बिलोंग्स टू एन. क्योंकि हमें पता है कि जो एक्स वाई भी है, जो ए बी है वो किसको बिलोंग कर रहा है? वो भी आई को बिलोंग कर रहा है. और एक्स वाई और जेड और टी है वो भी किसको बिलोंग कर रहा है? आई को बिलोंग कर रहा है. तो जो ए एक्स प्लस बी वाई होगा वो ऑल्सो बिलोंग्स टू आई करेगा. और ए जेड प्लस बी टी होगा विच ऑल्सो बिलोंग्स टू आई. नाउ so this is our left ideal. So left ideal which belongs to n, but when we check the right ideal, so that means SR. The right ideal हम check कर रहे हैं. This can be written as A, B or 0, 0 into that means second matrix. So this can be written as X, Y or Z or T. So when we do the multiplication of these two, the first row, first column, so this gives us AX, and first row, second column, this gives us AY, and second row, first column gives us BX, and this gives us BY. अब जो एलिमेंट और जो फॉर्म आ रही है इसकी, वो नॉट बिलोंग्स टू सेट है, तो वो एन को बिलोंग्स नहीं करेगी। एन में तो यहाँ 0 0 है दोनों, यहाँ पे एलिमेंट्स आ गया, so that's why this not belongs to n, so this is not a right idea, so this is not a right idea, so this is not a right idea. Okay, so hence we can say that hence n is left ideal but not a right ideal, but not a right idea.